RHS Pre-calculus presents Jimmy skateboards his way through trigonometry, defining right triangle trig. This is Jimmy's skateboard ramp. The opposite and adjacent side lengths meet to make the right 90-degree angle, and the hypotenuse and adjacent sides meet to form theta.
Assume that theta is an acute angle. Jimmy's skateboard will roll down the hypotenuse of the right triangle.
We find the values of the trig identities in this chart using the side lengths of Jimmy's ramp.
Sine theta equals opposite side length divided by the hypotenuse length. Cosine theta equals adjacent side length divided by the hypotenuse. And tangent theta equals opposite side length divided by the adjacent side length, and so on.
The other identities names are cosecant, secant, and cotangent.
Notice that across the chart, these terms are reciprocals of each other. For example, sine theta equals opposite over hypotenuse, while cosecant theta equals hypotenuse over opposite.
These trig identities work together to find any angles and side lengths of any triangle that could make up a ramp for Jimmy. But for now, let's focus on his favorites: special triangles.
There are two special right triangles. The first has angles 45, 45, 90 degrees. This makes it so that the opposite and adjacent side lengths are the same lengths. Sine and cosine of this triangle are both root 2 over 2. The tangent equals 1 because root 2 over 2 divided by root 2 over 2 equals 1.
The second special triangle has angles 30, 60, and 90 degrees. If 30 represents theta, then sine equals 1/2, cosine equals root 3 over 2, and tangent equals root 3 over 3. If 60 represents theta, then cosine equals root 3 over 2, sine equals 1/2, and tangent equals root 3.
Let's put Jimmy's ramp to the test, using what we know about special right triangles. Let theta be the angle that touches the ground.
If the hypotenuse of Jimmy's ramp is 4 feet, and the height of the ramp is 2 feet off the ground, find sine of this triangle. Assume that this is a special triangle.
We know that sine equals opposite over hypotenuse, so if we take the opposite, 2 feet, and divide it by the hypotenuse, 4 feet, then the value of sine equals 1/2.
Looking back, Jimmy recalls that this is a 30, 60, 90 triangle, where theta equals 30 degrees, sine equals 1/2, and we're done. See you next time when we learn about how Jimmy makes his half pipes.